Hey everyone, and welcome to this explainer. Today, we are diving into something absolutely fascinating, the MIT-licensed DeepSeek Harness developer preview. We're going to break down exactly how this framework acts as the vital runtime layer for autonomous AI and how it's fundamentally changing the way open source models actually operate out in the wild. So, I want you to think about this question for a second. What actually happens when an AI model gets hands, eyes, and a terminal? Because, a language model sitting on a server all by itself is really just a very impressive, very expensive autocomplete. It can generate text, sure, but it can't do anything. But the moment you give it a harness, it's a complete game changer. Suddenly, it can perceive real-world environments, run code, and execute totally complex workflows on its own. Here is our roadmap for today's deep dive. We'll be looking at 1. How an agent equals a model plus a harness. 2. The everything is a plugin concept. 3. The 4 runtime modes. 4. Performance and token costs. And finally, number 5, essential security and permission guardrails. Let's get right to it. Starting off with Section 1, agent equals model plus harness. Or, as we can think of it, the brain and the body. The crucial point to grasp here is that DeepSeek treats the language model strictly as the soul or the brain of the operation. By itself, it has all this intelligence, but zero agency. The harness steps in to act as the body. It provides the hands, the eyes, and the environmental perception needed to pull off multi-step, real-world tasks. It's the literal bridge between the AI typing out a line of code and actually creating a file, running a test, and deploying it. Now, to keep track of what this newly formed brain-body combo is actually doing, DeepSeek uses a really clever append-only session log. It basically takes the highly abstract concept of a context window and turns it into a tangible, visible timeline called a trajectory view. Because literally every system prompt, reasoning step, and tool call gets logged, you can jump in and search, fork, or even replay the agent's exact thought process. It's an absolutely massive win for observability and debugging. Moving right along to Section 2. Everything is a plugin. Let's look at the Cordis architecture. So, to avoid building this giant, rigid monolith, the system is designed around this brilliant everything is a plugin philosophy, which is all powered by the Cordis meta framework. It is so modular, you can seamlessly swap out models, tools, or sandboxes just by tweaking configuration files. And get this, what's really wild is that you can even plug in other coding agents like Claude Code or Codex as sub-agents. You can literally build out a multi-agent pipeline where DeepSeek acts as the boss, orchestrating tasks and delegating them to other models, all without ever touching the core source code. But how does a tool actually get used safely? Well, we can trace it through this guarded execution pipeline. When the model wants to fire off a tool, it doesn't just happen instantaneously. First, it hits a pre-execute phase where it checks permissions and policies. Only then does it actually execute. After that, it passes through a post-execute phase, maybe redacting some sensitive data, before finally logging a durable tool result. This ensures that safety and control are baked into absolutely every single action. All right, that brings us to Section 3, the 4 runtime modes. This is how we adopt the agent to the actual task at hand. The beauty here is that you are definitely not stuck with a one-size-fits-all setup. Standard mode gives you the full-blown coding agent with all the bells and whistles. Code mode is super interesting because it exposes tools through an SDK, letting the model coordinate multi-step TypeScript operations. Then you have minimal mode, which strips it all the way back to just 2 basic tools. And creator mode, which lets you experiment and build your own custom agent presets from scratch. Let's pause on minimal mode for a second because it is vital to understand its importance. DeepSeek actually used this exact minimal mode, just a persistent bash terminal and a simple string replacement editor, for their own official model benchmarking. They did this to prove a point. Your production numbers are going to depend heavily on the specific scaffolding you deploy. If you really want to see the raw, unvarnished capabilities of a model without a fancy harness masking its mistakes, minimal mode is your ultimate benchmark standard. Shifting gears now to Section 4, performance and token costs. Let's talk about the practical reality of running open models. Get ready for a pretty staggering number, 20 million. During a 35-minute test to build a complex, real-time International Space Station tracker app, the agent chewed through 20 million tokens over the course of just 2 turns. It was spitting out around 240,000 tokens at blazing speeds. But wow, it really highlights the sheer token hunger of these open models when you hand them complex, real-world tasks. Now, you might assume you always need the biggest, heaviest model for the job, right? Well, actually, no. When comparing the models, hands-on testing shows that the lighter DeepSeek Flash variant actually delivers a far superior cost-to-performance ratio for your everyday coding workflows. The flagship Pro model is undeniably fantastic, for sure, but you really want to reserve that heavy hitter for tasks that demand maximum deep reasoning effort. I know that 20 million token number from earlier sounds totally overwhelming, but here is the saving grace: cache hit rates. As the long run progresses, the interface reveals that cache hit rates can reliably climb to between 95 and 100%. Because the harness is so incredibly efficient at reusing context, it significantly offsets those raw token costs, making the whole system way more practical to run than it sounds at first glance. Finally, we arrive at Section 5, Security and Permission Guardrails. Safely deploying this AI workforce is absolutely critical. Look, giving an AI access to a local terminal introduces some very severe security risks. We have to know how to bound the agent's behavior. DeepSeek Harness handles this by treating approval and sandboxing as two entirely separate things. Approval asks, must the user confirm this action? While sandboxing asks, what system resources can this action actually reach? It's a vital distinction. A user mindlessly clicking approve on a pop-up is absolutely not the same thing as having a secure, hard-coded file system boundary. So, to prevent accidental system damage or worse, developers have to put strict guardrails in place. You should always run these agents in isolated virtual machines or containers. You also need to actively utilize the 4 permission tiers they give you. And please, avoid using the dangerous full access mode unless it is completely isolated and entirely necessary. Break your complex instructions down into smaller chunks, and always keep a human in the loop for big changes. Wrapping things up, DeepSeek leaves us with this incredibly profound idea. By offering an MIT-licensed harness alongside MIT-licensed open weights, they've shown us that a team can now run a capable agent stack end-to-end without a proprietary vendor in the loop. It begs the question, are we finally ready to break out of those closed-off walled gardens and start building our very own autonomous local AI workforces? It's a huge paradigm shift, and honestly, I can't wait to see what you all build with it. Thanks for hanging out for this explainer, and we'll catch you next time.